Welcome everyone. In the last video, we saw how the solar radiation is being measured using various instruments. Today we are going to the next stage where we are taking this module we completely dealing with solar thermal systems. So for that we should first know what is heat transfer, and its basic three modes. Like whatever I'm saying now is basically what you've learned from maybe your 5th standard or 6th standard science classes. So heat is simply a form of energy that is associated with the motion of molecules, and when the electromagnetic waves coming from the sun hit an object, they will excite the molecules of that object, causing them to move. So this molecular movement is what we call as heat. And heat always moves from higher to lower temperatures until they are equal, so that is known as a heat transfer. So if you place two objects next to each other, the warmer object will cool down as its heat is transferred to the cooler object, and the cooler object in turn will warm up. ഇത് വളരെ ബേസിക് ആയ ഒരു കാര്യം നമുക്ക് പറഞ്ഞിട്ടുള്ളൂ. വീടുകളിൽ അടുക്കളയിൽ പ്രത്യേകിച്ച് നമ്മൾ ചെയ്യുന്നതാണ്. ഇപ്പോൾ ചപ്പാത്തി ചുട്ട് കഴിഞ്ഞു, തവ നല്ല ചൂടായിരിക്കും. ഗ്യാസ് ഓഫ് ചെയ്തെങ്കിൽ നമുക്കൊരു കറിയുടെ എന്തെങ്കിലും ഒന്ന് ചൂടാക്കണം. എന്ത് ചെയ്യും, നമ്മൾ വീണ്ടും ഗ്യാസ് കത്തിച്ച് പാത്രം നോക്കി മെനക്കെടില്ല. ആ തവയിലൊന്ന് പാനിൻ്റെ മുകളിൽ വെച്ച് കൊടുക്കും, ഇല്ലേ? അപ്പം അതിനനുസരിച്ച് അതിൻ്റെ ചൂട് കുറയുകയും ചെയ്യും, നമുക്ക് നമ്മുടെ കറി ചൂടായി കിട്ടുകയും ചെയ്യും. ഓക്കെ, സിമ്പിൾ പ്രോസസ്സാണ് ഹീറ്റ് ട്രാൻസ്ഫർ. So the heat transfer is driven by the difference in temperatures of the objects, and it is proportional to the difference in temperature. The larger the difference between the objects, the faster will be the heat transfer. Okay, so more physical ways in the conduction, convection, and radiation. So conduction is the transfer of heat through a solid material from one material to another where the surfaces are touching. Again, so heat is conducted more easily through a solid material than through layers of material, even if the layers are held together tightly. So this is important as the conduction of heat through building materials is a major source of heat loss. Another method is the convection. It is the transfer of heat by moving fluid, usually air or water. So natural convection is caused by the heating and cooling of the air in a room as it contacts objects. As the air is warmed, it expands, resulting in it having a lower density than the cooler air around it. Since its density is lower than the cool air, automatically it will rise. And as the air cools, its density increases and it will sink, starting the process all over again. So I'm going to repeat it as cycle process continues. Air tanakanum chudavunum. This movement of air is what you call as the convection current. And radiation is the direct transfer of heat through space by electromagnetic waves coming from a warmer object to a cooler object. Heat radiates in all directions from a warm material and will warm all surfaces that are in direct line of sight of the material. Most objects that block visible light will also block radiant energy. So, മൂന്ന് ടൈപ്സ് നമ്മൾ മൂന്ന് കാര്യം പറഞ്ഞു. നമ്മുടെ ബേസിക് ഹീറ്റ് ട്രാൻസ്ഫർ എന്താണ്? നമ്മുടെ മൂന്ന് മോഡ്സ്: conduction, convection, and radiation. Conduction is mainly for solid materials. Convection is when you have by a moving fluid, air or water, and radiation is when it's happening through electromagnetic waves. Now we are going to learn about a solar heating system. So for knowing going to a solar heating system, you should be knowing what are the components in the solar heating system. So the first main component is collection, which means you need a method to capture the solar energy coming from the sun so that it can be converted into heat. So you have both two types, that is passive and active. And passive solar homes use the house design and structure to collect the solar energy, and active systems will use boxes known as solar collectors to capture the solar energy. Active systems use mechanical devices such as fans and pumps for the collection, storage, and distribution of solar energy. And passive systems don't use mechanical devices. Instead, they use design elements and basic physical principles such as convection, conduction, and radiation for the collection, storage, and distribution of solar energy. The next main component is storage and a method to store the heat that has been collected. So solar thermal energy can be stored using thermal mass, water tank, rock bins, etc. that can hold this heated air. And next comes the distribution, and so a method to distribute the heat throughout your home. It can be done either by mechanical means like fans and pumps, or by basic physical principles of convection, conduction, and radiation. So let's start with the solar thermal collectors. So in this device, the solar energy can be stored either as thermal energy or as electrical energy. The solar energy collection involves the absorption of solar radiation by exposing a dark surface to the radiation. So the thermal energy collected of low temperature will be used for heating, and those of high temperature will be used for the generation of electrical energy. The solar thermal energy collector is an equipment in which solar energy is collected by absorbing the radiation in an absorber and then transferring it to a fluid. So basically there are two types of collectors. Flat plate solar collector, which is also known as FPC, and then concentrating type solar collector. Flat plate features are and optical concentrator collector area, absorber area almost same, the numerically same, value same, then efficiency and the temperature of the working fluid can be raised only up to 100 degrees Celsius. ഇതിന്റെ appear disadvantages ഒക്കെ make up ചെയ്യാൻ വേണ്ടിയിട്ടാണ് we had this concentrating type solar collector. So the area receiving the radiation will be several times greater than the absorber area, and you're going to have higher efficiency and optical concentrator area flat plate. Shielded mirrors and lenses are used to concentrate the sun's rays on the absorber, and the fluid temperature FPC 100 degrees Celsius vare pattullu. Concentrating type it is possible up to 500 degrees Celsius. So let's see what is a flat plate collector or FPC. It is a simple and effective means of collecting solar energy for applications that require heat temperature below 100 degrees Celsius. Two types under air collector type and fluid collector type. And you can have two type design structures under types. Okay, for the control of flow of air and fluids. So let's see a flat plate collector. Absorber plate fluid tubes, then you have a transparent cover, and this is insulated as well, and the solar radiation both direct and diffuses coming up. Okay, in operation it shows a schematic diagram of an FPC where air or water is used for carrying the collected heat energy. The metal plate with blackened surface is used, and the heat collected from the surface to the point of use is transported by means of air or water by circulating below the collector plate. The place and method of circulation of fluids depends on the design of collector. The typical diagrams are shown in figure B. That is figure B, and then we've got a type in the first one, the tube is below the sheet. Okay, second, the tube is above the sheet, and then the third type is the tube is in the sheet, and the fourth one is known as corrugated. So these are type of liquid collectors. Now you can also have air collectors. So the flow may be below the absorber, above the absorber, again below the absorber with fins, and the last one is corrugated, which is again below the absorber. So three types of flat plate collectors are available. Okay, so let's see the components of a flat plate collector. Basically 5 elements are ullada. First is the absorber system. So it is going to absorb the incident solar radiation and transfers it to the working fluid. The cover and down, the cover is reducing the heat losses from the absorber and also permits the solar radiation to be transmitted through it. You have an insulation which reduces the heat loss from those parts of the absorber that are not exposed to the solar radiation. Then you have a working fluid system which consists of the fluid itself and necessary channels to distribute and bring the working fluid into thermal contact with the absorber. And the final part is the structure which is needed to hold the various components in proper position and to support the weight of the collector. Now usually the types gas type flat FPC fin attached corrugated absorbs use കാരണം surface area കൂടുന്നതിനനുസരിച്ച് വരുന്ന gas അല്ലെങ്കിൽ fluid which comes in contact with the surface അതും കൂടും. So more heat transfer takes place. That's why you're using such a type. But the major advantage is that the system will be free from corrosion and freezing of fluid. Which a liquid flat type ആണെങ്കിൽ ഈ രണ്ട് problem ഉണ്ടാവും. കൊറോഷനും അതുപോലെ തന്നെ ഫ്ലൂയിഡ് ഫ്രീസ് ആവുന്നുള്ളത്. So let's just see the advantages and disadvantages of FPC. The advantage is that no complicated tracking mechanisms are involved and the construction is relatively simple. And we have two types of solar radiation, beam and diffuse. Both can be utilized in this particular type, and easy manufacturation and the cost is less. The disadvantage includes that it can have a temperature limitation of only 100 degrees Celsius and it is comparatively less efficient. So here in this diagram, this shows where we saw that there are two ways by which you can collect and use using the collector. Okay, so the first house, that is A, the collector is being mainly used for hot water purpose only. So as you can see, the solar radiation is heating the collector along with the water that is contained inside. And in the second stage, the hot water, which can reach up to 90 degrees Celsius, circulates between the collector and the buffer storage tank. The third portion is the heat exchanger. Heat exchanger releases solar heat to the water in the buffer storage tank. And in the fourth portion, the buffer storage tank is providing heat both at night and on days. So basically we can use it for hot water as well as for heating. We'll stop this video here, and in the next coming classes we can go into see on the concentrating type solar collectors. Now we saw on the flat plate collectors, that is FPC. Thank you.